So today's session is about boosting your Android CI through integrating build cache. Let's have a quick look at today's agenda. First, I'm just going to do a quick introduction of myself, just to make sure that everybody knows me. After that, we are going to go into the first steps and do a bit of an introduction on caching. After that, we will look at some possible improvements and some common issues. And if we still have some time at the end, we can have some questions as well. Or if we wouldn't really have enough time for that, we have a booth here at droidcon, so feel free to come by our booth and let's have a discussion around caching and mobile CI/CD and DevOps in general. So I'm Tamás Bazsonyi, working as part of the solutions engineering team at Bitrise. I initially started my career as a full stack engineer. After that, I moved over to the manual QA side of things. After that, I did quite a lot of test automation, both on the Android, iOS, and also on the web side of things. After that, I started working in mobile development, working both with Android and iOS applications. Then I joined Bitrise, and through the support team, I started working with our customers, addressing their issues with their daily CI/CD executions. And in the last a bit more than 3 years, as part of the solutions engineering team here at Bitrise, I basically do the same thing, just more concentrated on the few customers that are assigned to me in the sales pipeline itself. So let's start with a bit of a question. This is a small quiz. Let's just look at how much faster can builds get by integrating remote caching in an ideal case scenario. And I would just like to ask everybody to raise their hands when they hear the answer that they think is correct. There are a couple of plushies down there that you can win if you select the right answer. So who thinks that builds can be 50% faster? Who thinks they can be 70% faster? Who thinks 99% faster? And who thinks 95% faster? 95 is the correct answer, and I think you were the first there. So yes, so in an ideal case scenario, builds can get even 95% faster. Let's talk a bit about remote caching. What is it? What is it good for? Remote cache is basically used by a team of developers and or a CI system to share build outputs. Gradle is basically generating these build outputs when you are executing your builds or executing your tests. And with a shared cloud solution, you are able to reuse those task outputs on the developer machines or on your CI environment as well. Let's look at the configuration itself and the flow, how it looks. So you can see here that the developers are triggering builds on their own machine. The caching itself is downloading the unchanged task outputs. After that, Bitrise is building any kind of tasks that has changed task input and saves the task output to the remote build cache. And on the bottom side of it, you can see locally when developers are triggering builds, it is still downloading any kind of unchanged task outputs, where basically the task input is the same as it was during the previous execution. And the local builds are executing those tasks that inputs changed. Okay, so this sounds a bit complex and adds additional complexity to the build process itself, but is it worth the effort? So what can you expect when you are implementing a build cache solution? It would allow you to have exponentially faster builds, consistency and reliability for large teams as well. And because the builds are taking much less, developers are getting feedback much faster, the developer happiness improves as well. Let's look at some of the bottlenecks that are associated with a build cache implementation. The speed, instead of pure machine resources, is now linked to the network latency of retrieving the cache entries. This heavily depends on the geographical location. So if your build server is located in the US, but your cache server is located on the other side of the world, it's possible that a build cache solution wouldn't improve your builds, but it could potentially slow it down. So you need to ensure that there is minimal network latency in the system. And it's also affected by the cache read speed as well, which is basically the cache server itself and how efficiently it is operating. Another bottleneck is the implementation time. Simply the time it takes to put together the cache server solution. And the next part is super important. I listed it twice as well, security. So you always need to make sure that the security implementation and security considerations match across your whole mobile DevOps setup itself. So how does build cache solution help on this? In our caching solution, for example, you would be able to make use of a remote cache server, which is located in the same data center as your builds. With this, you would be able to achieve faster CI builds. As I mentioned previously in the quiz as well, you can go up to 95% faster than a clean build in an ideal scenario. Global CDN infrastructure, which ensures that even though your build and cache servers are located, let's say, in the US and your developers are located in Europe, because of the CDN network, these local builds are still faster and able to speed up. And it decreases the egress cost that you are incurring on the cache server side. And the last point is the fully managed solution, just like on the CI side, where you don't need to ensure that you have people with top tech knowledge to be able to put together a configuration that would be able to serve your caching needs. And the security is on par with the CI solution that you are running as well. So after so much data, let's have another quiz. How much faster do builds typically get with remote caching? So this is not ideal case. This is more like based on the performance improvements that we are seeing with our existing customers and customers who are trialing Bitrise Build Cache. Who says it's around 5 to 10%? Oh, nice. Who says it's around 30 to 60%? Okay. Who says it's between 50 to 99%? Huh? Who says it's above 99%? Oh, nice. That would be awesome. The correct answer is 30 to 60%. So these are the cases where the projects are necessarily heavily modularized. There are code changes, of course. So basically the usual, not hyper advanced use cases. And you were the ones nodding there, or you were the one nodding there.
You can throw.
Awesome. All right, so let's talk a bit about some examples of the remote caching improvements and what it brings. We were testing with the Amaze File Manager as a sample application. The original duration was around 28 minutes, 43 seconds. After we introduced build cache, that execution time went down to 3 minutes, 48 seconds. So it was quite an impressive improvement. For the next part, I wanted to quickly look at the whole process of integrating caching. Sorry. So for this, I'm just going to switch over to Bitrise and quickly run through the setup process itself. I'll just quickly add the application. I'm just going to use a sample app, which is a basic to-do list. Through the integration, I'm just automatically adding the SSH keys and all that. The next part is basically just configuring the project itself, ensuring that everything is there to download correctly the repository and to have a list of default configurations. And once we have that, I'm just going to go with the default configuration itself. And we already have the first, or the application created. And just let's have a look at how you would be able to integrate caching into this flow. Yeah. I'll just need to select the step, add it to the workflow, and basically that's it. So now we have the step within the workflow as well. So the next execution will take longer than the original execution. This is simply because it is taking time to initialize the cache itself that can be reused in the next executions. So I'm just going to look at 2 previous executions. You can see here the first build that took 2.5 minutes to run. This was the one that initialized the cache itself. And the other one took 1 minute, 28 seconds. We can look at the exact execution itself as well. Let's focus on the unit test step because that's the one that is making most use of the build cache itself. You can see here that it was 1 minute, 43 seconds to execute it. And here on the next build, you can see that the execution time went down to 45 seconds. Perfect. So now we have set up with the correct caching configurations. We had the initial run that generated the cache archive, had a second run which already produced some nice results. But what happens if you're not seeing that good results initially? That can be caused by quite a few different things. For this, we created a critical path analyzer. that would allow you to look at the critical path, which is basically the longest running tasks that are dependent on each other, and try to optimize this. Let's just have a quick look how the Gradle task graph looks. You can see here that the highlighted tasks are the ones that are part of the critical path itself. And let's just look at the UI as well, how this looks. Here you can see the first executed small tag there, which basically highlights which task was part of the critical path itself and gives you a hint where you should start your optimizations. Yeah. And before going into all that, I just wanted to give another quiz because there's still a bitbot left there. How much time does it take to set up your first project with the Bitrise build cache? Show of hands if you think it's less than 10 minutes. All right. Who thinks it's 2 weeks? 2 months? More than a year? Perfect. It was less than 10 minutes as I showed you like 5 minutes ago, so congrats. Perfect. And for the very end, basically, I just wanted to quickly run through a couple of common issues that can be happening with the project itself that can cause cache misses. For example, the version code. Changing dynamically the version code can affect the cache hit rate as well. This would mean that quite a few tasks would be rerun simply because the version code or the version name was changed within the build.gradle file. Another point is dynamic environment variables. Whenever you are referencing dynamic environment variables, there's a good chance that those would be different. For example, on Bitrise, the temp folders won't necessarily be named the same throughout each and every build. So this can cause re-execution of the different tasks. The third part is the Gradle and Android plugin versions. It always makes sense to try and keep these versions as up-to-date as possible, because with older versions, not as many tasks are cacheable as they are with the current ones. The fourth point is diagnosing based on task inputs. Basically, looking at the different task executions, seeing the task input hashes, and comparing those between executions to spot which are the tasks that are getting different inputs between the different builds, and digging into why those inputs changed. And the final part is, of course, modularization. As better modularized your project is, the easier you would be able to cache the different task outputs. And that's it for today's session. Thank you so much. I think we only have a single minute left, so if you have any questions, feel free to drop by our booth. Happy building!